Hi, I'm Abigail Spence, and this is Lab 2, Lines of Charge. The purpose of this lab is to determine the force and charge of one tape on another tape when it is a certain distance away from each other. But what makes this lab different from Lab 1 is that we are considering the charge to be distributed evenly instead of a point charge. In this video, I'll be covering the principle of electric charge, polarization, the principle of momentum, Newton's third law, and distribution of charges. By the end of the lab, I got the force to be 2.08 times 10 to the negative 3 newtons, the charge based on the point charge method to be 6.25 times 10 to the negative 9, and the charge based on the distributed charge method to be 1.744355 times 10 to the negative 8. To recap the observation of Lab 1, when two U-tape interact, they repel each other because they have like charges. When a U-tape interacts with a neutral object, such as a book or my hand, it is attracted to it due to a shift and separation of opposite charges on the neutral object. This process is called polarization. Lastly, when I negatively charged a plastic pen by rubbing it on my hair, it attracted the U-tape. This means that the U-tape has to be positively charged. Next, when conducting the experiment, the goal is to float one tape above another. This is because the two tapes have the same sign charge. The momentum of the floating tape is known to be unchanged based on the momentum net force equation. If the change in momentum is 0, then the net force on the top tape is also 0. Therefore, if net force is 0, the two forces acting on the tape, the electric force and the gravitational force, must be equal and opposite. This is supported by Newton's third law. I then measure the distance between the two tapes when the tape on top begins to float. This distance was 1.3 centimeters. Other measurements included the length of one of my tape was 0.212 meters, which makes the mass 2.12 times 10 to the negative 4 kilograms. With all the measurements and observations collected from the experiment, we can then find electric force. Since we know that the magnitude of gravitational force and electric force are equal, by finding the gravitational force, we will know the magnitude of electric force on the tape. Since mass times gravity is 2.08 times 10 to the negative 3, this is also the electric force. Once we calculate the magnitude of electric force, we can plug in the force and distance in the electric force equation to solve for the point charge of each tape. The charge on both tapes are assumed to be the same since they were created the same way. Therefore, we can then solve for Q to get the charge of one point charge to be 6.25 times 10 to the negative 9 coulombs. However, if we assume that the charge is distributed across the tape, the electric charge would be 1.744355 times 10 to the negative 8 coulombs. This number was found using the glow script code. This is my glow script model of the experiment. Each tape is assumed to be 10-point charges each, and each charge produces an electrical force on the opposing point charges on the opposite tape. Assumptions made throughout this experiment was that each U-tape had about the same amount of charge evenly distributed along the length of the tape. Following my model is all the code used to calculate the distributed charge, as well as gravitational force and electrical force. In conclusion, two questions were posed. What if I had modeled each of my tapes as a single point charge like in the previous lab? If I had modeled each tape as a single point charge, the value of the charge would have had a 95% difference from the charge value computed based off the distributed charge. The single point charge estimate was much smaller than the distributed charge. The next question is, why do these estimates differ? what value is most likely to be closer to the real value and why. The estimates differ because by considering each tape to be a point charge with all the charges located at the center, we neglect to consider the charge's effect along the entire length of the tape. The estimation based on the distributed charge is more accurate because it considers the charge's effect along the entire length of the tape, which includes the different angles and magnitudes the charge is applied at. Thank you.